Good day, ladies and gentlemen. I'm Sauradeep Sarkar, your host for today's webinar. Thank you for standing by and welcome to the E3 India webinar on leveraging ArcGIS Platform and CityEngine for GIS-based Master Plans. The speakers for today's webinar are Seema Joshi and Vinay Sawant. Seema has over 23 years of experience in the GIS industry and is currently the Senior Division Head, Strategic Pre-Sales and Technology Solutions at E3 India. Vinay is Manager Pre-Sales and has more than 8 years of experience in GIS industry. Seema and Vinay will share their experiences on how ArcGIS Platform and 3D capabilities of E3 CityEngine provide a complete set of tools and end-to-end GIS-based master plan creation and maintenance. At the onset, few ground rules. For the duration of presentation, all participants' line will be in listen-only mode. We'll have a panel of E3 India experts from other industries and technology areas on the call to answer your queries you may have. We will have the Q&A session post the presentation. So meanwhile, if you have any questions, you may also send them across to all panelists using the chat window on the right-hand side of your console. And now, without any further delay, I would like to hand over the proceedings to our first panel member for today, Ms. Seema Joshi from E3 India. Thank you, and over to you, ma'am.
Thanks, Sauradeep. Good morning and a very warm welcome. Today we are here for this webinar on leveraging ArcGIS Platform and CityEngine for GIS-based master plans. Let us explore in this session how we can leverage these technologies for the key requirements of master plan for AMRUT and Smart Cities initiatives. Now, before proceeding, I am representing E3 India, which is a joint venture between E3 and NIIT Technologies, and we have more than 350,000 customers worldwide, and with more than 50,000 customers in India. So coming to this key theme of today's theme, why we need master plans first of all. So the key, as you all are aware, the key requirement for master plans is for an orderly and systematic development, we need a complete base data and information in a proper systematic manner. Now, as we know, in the master plans, the key functions as per the directions are why we need master plans is to guide development of a city in an orderly manner and to organize and coordinate complex relationships between urban and other areas, and to chart out different course of growth, changes, try to direct physical development in the city in relation to its social and economic characteristics, and provide a resource mobilization plan. Finally, to facilitate the orderly and planned development of cities in a sustainable manner with ultimately help for good governance requirements. Now, as of now, what are the key challenges we are experiencing in master plans? If we look at various experiences in the past, hardly 1/3 of urban centers have some sort of master plan available with them, which in many cases is just a policy document and not really in use. Many master plans have been prepared by agencies, but implementation is not that encouraging as of now. Preparation of master plans takes very long, which makes base data outdated most of the times. Rather, non-availability of the latest base maps is a key challenge here, and which results in great difficulties for the field data collection and visualization analysis. Now, lack of adequate systems for maintaining base data hampers the informed decisions by the decision makers and local authorities. And manually, if you look at the past master plans, the graphic presentations and the manual graphic presentations in the map makes it very difficult for the various agencies and implementing authorities to comprehend it and utilize it. As there are no efficient systems as of now in place for data storage, retrieval, monitoring, sharing, planning, it becomes extremely difficult to use these master plans for various smart cities and AMRUT and digital reforms requirements. So here comes the need to prepare master plan using state-of-the-art technology. Now, if you look at this slide here, under this Digital India initiative, where we are talking about this AMRUT and smart cities as a key initiative, the key objective is to improve quality of the life for the citizens, which calls for required infrastructure and build required amenities for the citizens. Now, this infrastructure should meet following requirements leading to the provision for better services with respect to water supply, sewerage facilities, septic management, stormwater drainage management, reduced flooding, pedestrians and open space management, parking, open spaces, green area management, enhancing amenity values for the cities. So these are the key requirements when we talk about the citizens' quality of life, and that is all based on master plans, properly prepared master plans. And that is where, under this mission, under this AMRUT and Smart Cities mission, there are some 500 cities which were taken up initially, which are having a population more than 1 lakh as of now, to start with preparation of these master plans and start leveraging it for various smart cities requirements. Now, as of now, if we see this status, there are SLIP, the state level implementation plans and SAPs, they are already prepared by various states and implementing authorities for desired reforms. And underlying, again, if we reinforce this, underlying key requirement for all these initiatives, whether we talk about smart cities, AMRUT, Hriday, heritage cities, the key underlying requirement is the GIS-based master plan, which is required to improve the efficiency and the standardization of all these initiatives. Now, if you look at this slide here, we have a typical functional workflow for a master plan. In a typical organization who is involved in master plan preparation, the key requirement is, as we understand, is to have a standardized data model, where all different kinds of data, which is existing land use patterns, existing roads and transportation, existing infrastructure of the city, they are all integrated here along with various base maps. Now, on top of these layers, there are certain MOUD guidelines which needs to be incorporated. There are certain building bylaws which has to be incorporated in these master plans at the time of preparation. And here we talk about rule-based cartography, requirements, codification, standardizations, domains, subtypes, building bylaws. Now, in addition to these, we have various MIS parameters from different sources which are required for master plan preparation. For example, we have demographic profile of the area, socio-economic profile of the area, various infrastructures, and their MIS parameters. Finally, once all this data is there, then the QA/QC is one of the critical requirements where we need to ensure whether all these bylaws and all these parameters are integrated properly without any errors. Now, once all these data is available, then we need to have a platform where different planners can access this data from starting from the town planning, town level. Then once they are through with their analysis, they need to do this analysis, and then they, using their survey teams and field teams, they perform various surveys and validate their data and analysis, and then they are expected to submit their master plans for reviewing and approval purposes. Now here again, as of now, there is no standard workflow followed, but there is a key requirement where we need to ensure that the proper workflow has to be there in place, which allows step-by-step information to be integrated. Various applications and tools are required to execute all these processes. in a proper way. Now, once this data is there, prepared, then it has to be published in the form of various base maps and tools. It has to be published for various approvals, and then different approving agencies, authorities, starting from this senior planners, then we go to the chief planners, and at various levels the same information is accessed for approval purposes. And if there is any challenge, they need to again share it back for necessary incorporation of necessary changes. Once this draft master plan is ready, then it has to be shared with the citizens for a proposed master plan, where they are expected to give their feedback if they are requiring any changes, any modifications, or any enhancements in their areas, or if something is missed out. So once this feedback is available from the citizens, then it has to be incorporated again by the town planning in the same sequence and the same workflow. So what in a nutshell, what we are talking about is that in a typical master plan workflow, starting from this preparation of the schema, standardized data model, then applying rule-based cartography, incorporating all MOUD guidelines and building bylaws with respect to those cities, then doing analysis with the help of GIS to identify query locations which are not meeting those parameters or which are meeting the required parameters. And after analyzing this, then the planners are expected to take their decisions and prepare those master plans. So with this, if we see here a high-level workflow, this is a typical workflow where it is expected that there is a platform, GIS platform, which integrates different data from various sources like existing NUIS data or other spatial data available, some auxiliary data related to geomorphology, physiography, this contours, terrains. Additional data maybe if there are some gaps in the data, because as we all are aware, when we are doing a city planning, our data is not always updated. So we need to fill up those gaps using some additional data available. Then we have MIS data, certain imagery, raster data has to be accessed from various platforms. Sometimes we even need live weather feeds in order to identify and analyze weather conditions of that city for required planning purposes. Once all this data is available, then it has to be integrated in the GIS platform in a seamless, standardized GIS database where all these validations are applied. And then we, and further in integrating MOUD rules and guidelines. And once all these things done, then the process starts, the complete workflow of master plan preparation starts, where initially town planners analyze and prepare this data, forward it for the review purpose, get necessary approvals, and finally released by the chief planners for the release for the draft as a proposed plan to various stakeholders. So typically this is a complete workflow which is followed, which has to be followed in a master plan. Now if we see here, we have gone through this complete workflow, the ideal workflow for a typical master plan preparation. So are we really preparing GIS-based master plans as we are expecting in AMRUT and these requirements? Are our master plans completely geo-enabled, which can be accessed seamlessly in our smart city applications, which can be seamlessly integrated with our smart city applications? As of now, well, we need to see there are still few gaps. So here we see in the slide that we have very good technical experts available, we have excellent data also available, we have advanced tools available, technologies available, state-of-art hardware, software is also available. So what is missing as of now? Why we are not able to have those master plan in such a form which can be seamlessly accessed by various agencies for their various applications requirements. So let us see in this session here how we can leverage GIS, ArcGIS ESRA platform along with CityEngine for for preparation of GIS-based master plans. Now, as we are aware, most of our departments, they are already using GIS in most of the cities. We talk about infrastructure, housing, PWD, governance, planning, ULBs, transportation, PHED and all. They are having GIS already in place. So what is the problem? What is the need here? As of now, all these agencies, they are working as silos. But for the preparation of the master plan, we need to access updated, real-time, latest data to integrate and see the current situational awareness, to have awareness. So as of now, the situation is that all departments, they are having data but in silos, but there is a need to have a collaborative platform where we can access those data directly without really copying and pasting and moving the data here and there using CDs and USBs. We can directly seamlessly access data services from various departments, get access to the latest data available, and use that for master plan preparation. So this is what to start with, we need. Now here, ArcGIS platform, but for that we need a platform where we can access services. So here we have ArcGIS platform, which provides this environment, this framework, where all this data coming from various sensors, sources, topography, imagery, different global and local data providers, and that has to be integrated, managed, and shared with various agencies and authorities for master plan preparation requirements. Now, if we go in detail, what value addition GIS should give, or what value addition our ArcGIS platform is providing in the process of master plan preparation is. If you start from this left-hand side, this is our existing layers. I mean, as of now, we are having various existing layers in the CAD format, in the shapefile format, rasters, MIS, some survey data, some services. So that is what we are having right now. Now, on top of it, as per the existing structures, standards, we are accessing the data. Town planners are simply accessing this data, and then they are just using it locally, using their local tools to prepare master plans. But the challenge here is, what value addition is GIS platform, or in the earlier slide where I mentioned, are we really using GIS capabilities? Are we leveraging GIS properly here? This is how, in this slide, we are showing that this is how the GIS has to be integrated and leveraged. So first, we need to have a platform where we can integrate various sources of data, various sensors, various information seamlessly without any conversions, and that to latest updated information. Now, once that data is available, before that, before publishing the data, we need to have a standardized data model in place. Now, when we talk about standardized data model, where we need to have standardized cartography, so all these things has to be there in place where GIS can really play a key role. In the subsequent slides, we are going to explore some of these things in some more detail, little more detail. We need to have integrated URDP-FI guidelines, building bylaws. Then we need to have advanced connected, disconnected, rule-based editing, some of these workflow-based processes, QA/QC. So here in the subsequent slides, let's quickly have a quick look. So when we talk about this geodatabase, the first requirement is to have a standardized enterprise geodatabase, which should provide not only the feature classes in the form of point line polygons, but it should also provide us information related to the rules which needs to be followed, the domains and subtypes, and those kinds of standardization has to be incorporated inside this. And here, this geodatabase support this creation of this environment. Now, once this data schema is ready, data feature layers are identified, and these, if you see, this is the AMRUT, as per the, on the right-hand side, as per the AMRUT standards MOUD has provided, base layers, building layers, other layers, urban layers, and all. They need to be incorporated here, and once they are available, then standardized cartography has to be created on top of it. So GIS creates data models along with the standardized cartography. Now this cartography, what we are talking about is, it's not just plain simple polygons and lines, features like that, but cartography here, if you look at in this middle of the slide here, these rules with respect to the flyovers and bridges. A flyover is always shown inside the map, or has to be shown always on top of the roads instead of below the roads or crossing the roads. Same way we have rivers, and if you see on this lower side, these junctions of the rivers and all, this cartography should be self-explainable, and here in GIS, we can create these automations, we can apply these automations that it will automatically take care for these cartographic enhancements. Now, once this data model is available, then we are required to go to the platform where we publish this data. Along with this data, we can integrate data from various sources, like there are quite a few services available. Then we have big data, we are talking about big data integration, we have various maps and spreadsheet data. Social media is also equally active nowadays, so data has to be incorporated from them as well. Various sensor networks and imagery. So what we are trying to show is that once the data model is there in place, we are publishing it, then on top of it we access various services and live feeds, maybe from UN portal, from other global portals, and then we need to implement a complete workflow-based system. Now this workflow-based system allows us to monitor end-to-end activities of the complete master plan preparation, where it implements standardized processes for the editing, process for the cloud quality control, cartography, rules and all, and then step by step, it will enforce complete sequencing in a standardized way. Here, in fact, I'll just quickly go back here on this slide again. On the left-hand side, I just missed this. On the left-hand side, we see that in this workflow, we have dashboards available which can give a complete status as of now where we are in the master plan preparation. Because one of the biggest challenges which we observed in front of authorities is that how many towns are completed, which town is still in the progress, where there is gaps, where there is a challenge. So it's difficult to monitor all that. But here this particular platform provides complete integrated dashboard which gives a complete picture in one go what is the status right now of the master plans. Now information accessed once these master plans and workflow is implemented, that different master plans are shared and accessed by various stakeholders. Various apps are created which are accessed by various stakeholders. Then we can access even live feeds. If you see here, world traffic feeds and other Bhuvan data, other feeds from various other sources, soil data, geology data. So using all these apps, town planners will do various analysis and they prepare master plans. And while the process of the master plan, because it requires intensive surveying as well, surveying of data from the field, capturing and updating information from the field. So here this GIS platform provides integrated mobile and field-based editing, both connected as well as disconnected mode. Because we we know that in fields and especially in the rural areas and in the remote areas, there are connectivity challenges. So here this GIS platform provides access both as connected as well as disconnected mode. Now once this data is captured, then the next step is to do a complete analysis and geodesigning of the area. So for the master plan preparation, as we all know, there are certain building bylaws has to be applied, there are certain MOUD rules has to be followed. So here this ArcGIS platform and CityEngine together, they provide this environment to the planners to use various tools and capabilities of CityEngine where they can apply those building bylaws and various rules and do a complete geodesigning. Now let me hand it over to Vinay just to show a quick demo how this CityEngine helps us in doing geodesigning.
Thank you, Seema, and good morning, everyone. Before taking a deep dive on the smart city planning and designing concept, I would like to give a bit of a brief about the solution, what CityEngine exactly is and what it does. CityEngine is basically a three-dimensional modeling application by ESRI and is specialized in generation of 3D urban environment. With the procedural modeling approach, CityEngine supports the creation of detailed, large-scale 3D city models. CityEngine mainly works on architectural object placement and arrangements. So I'll mainly focus on the data formats which are supported directly into the CityEngine so that it will be easy for users to import those things directly onto it. I'll explain what is rule-based modeling core, mainly the SWGA rules, how we can write it, the parametric modeling interface from where you can manage all your properties of the building or the street or any other object, map control city modeling, street network patterns and all. Here at the left hand corner, if you can see, there is a navigator panel. Navigator is the panel is the one where you will put all your data. Let it be assets. Assets when I'm saying the building, hotel, the facades and all those details. The data which is in the form of CAD or in a JR format which you are importing from ArcGIS. The maps which are already there, some satellite imageries and all. Some of the models which are already there and which you want to use in your project. Scenes which we create using multiple rule files. Here at the bottom you can see you can get the details about the particular project of ours. Scene window is the one which gives you all the detail, what all layers are available, how many number of meshes, development area, the layers which you are having. In the center we are having a map view which is available there, and all the details is available there in the inspector window. That means whenever you make any changes there with the inspector window, it will get reflected there on the map itself. So it's a dynamic city layout, changes can be done onto it. There are multiple reports which can be directly generated into it, like FAR and all. Some object attributes, if it is available there, just taking an example, if you are having a building is having 50 meters of a height and X could be the width, that information can be directly shown here and can be used for multiple purposes. Now I'll go further. Whenever we plan a smart city, there are three ways of implementing it. One is redevelopment, second is retrofitting, and then the pan area development. And there is one thing very common in all three, that is location. So location plays a very important, critical role, and it is pervasive. So what all are the major components of a smart city development? That is planning, designing, construction and implementation, operation and maintenance. Out of all these functions, planning and design plays a most important and a crucial role, and the maximum time of a planner goes onto it. The major component of planning and designing is zoning. So I'll mainly focus on the zoning part itself. because zoning is the one when we decide how much of an area of a city should go for residential activity, how much area of a city should go for industrial activities, how much of an area should be there as an open land. So as you can see in the map, there are multiple color themes available. As I click on it, on the red one, it is showing on the red hand side, it's a residential activity. That means the usage is for residential activities mainly. As you can see on the map, when I click on some other color, it is showing as industry. The same way, if I'm clicking on some another color, it is showing it in the form of office. Now what we'll do, we will focus and try to create one new zonation. Okay. So what all are the important roles of doing a zonation activity? That means maintaining and suggesting a building offsets and the setbacks, maximum permissible height into a particular zone. Taking an example, this as a single parcel. Okay. Here we are saying the front setback should be 25 meters, 25 feet. So in a sense, only the area which is inside the boundaries can be used for constructing the buildings. So that way we can manage this thing. What should be the maximum height of the building inside that particular zone? In this case, we are saying as 50 meters. Okay. Similar way, we can set multiple properties, and there are visualization patterns available. For example, currently we have selected the skeleton. This way we can select the transparent, which will give you a more realistic view what could be the maximum height of the building. We can select no horizontal surface, that means there will be no roof kind of a thing, only the side walls available. So this way we can select multiple scenarios. Now we'll go one step ahead and we'll try to create a building inside the zone. You click on a building, you can get many properties available there on the right side of the window. What these properties says about the building? That the main length of the building is 25, main depth 25, the formation of the building could be rectangle, shape L or U. Taking into consideration, I am saying shape L. Building rotation can be done automatically. We just need to set the values here. Okay, it will get changed automatically. Now the best part comes into picture. Here you can see one building is shown in red. That means it is coming out from the designated zone which we have assigned for the building construction. So what we can do, we can make the changes here, and it will automatically get reflected there on the map that this much height of a building or the depth of a building can be done. I'll go one step ahead. Currently, the maximum height of a building under that particular zone can be 50. But here, if I say 14 number of floors needs to be constructed, here automatically it will show it is not possible because it is out of the maximum permissible height. So we can set it accordingly. Okay. And what more we can do? We can say, if taking an example, this is a 13-floor building, we can say 3 floors can be used for parking lot. We say 3 floors can be used for as an office space, and then the public area. Okay. Here we will assign the numbers, and automatically it will get reflected there on the building. So this way you can do the zonation part, you can plan the activities accordingly. So this way we can do the zoning part. And if you want to create a road, because creation of road is equally important whenever we plan a city. Okay, we'll do a smart polygonal road creation. We'll select it. We'll make a selection so that we can extrude it, and accordingly an overbridge can be constructed in this way. So once we create all these things, we can share it onto the web. So Seema ma'am will take you further on it and will explain how we can take it further. Over to you, ma'am. Thank you.
Yeah, thanks Vinay for showing how we can leverage CityEngine as a tool for geodesigning requirements. Now, in CityEngine, as we have all seen, that the zonation can be done, and then finally the buildings and as for the zones, different kinds of buildings can be planned. And it is all, what one interesting thing is that on the right hand side there was a panel where we can set all these building bylaws and MOUD rules as the default values for that particular city, and they are all configurable, further configurable, that in case if any changes are required with respect to that city, they can be changed and configured. Now, once this thing is done and the base planning is done, base geodesigning is done, then planners are required to execute and perform various analysis to take decisions where they should put a new facility, where they should put new infrastructure, where they are required to expansion plans and all. And that is where we'll see how here in GIS they can do it for that. Yeah, sorry. So here if you see that once this thing is done, now zonation and prioritization, once this thing is planned, then planners use this particular base map, the zone map which was created just now by Vinay. The zone map is used, and then it is identified where the urban sprawl is, where the growth is happening in the past, what are the past trends. So planners can do this analysis using various tools available in GIS and prioritize accordingly. In addition to that, another key important requirement is environmental and legal compliances, which needs to be incorporated in their analysis and to be incorporated in their master plans. So here again, GIS can play a key role where it helps us in identifying which are areas environmentally sensitive, what is the site suitability for putting and placing a new industry or proposing a new industry and all. So these are the where the open spaces can be planned, where those garbage dumps and those sites can be planned in a city with respect to the residents and this other infrastructure. So these are various analysis which town planners can do with the help of GIS tools, analysis tools can directly help them in arriving all these results. Now, once this analysis is done, then there is a detailed designing and layout they can plan where they should have this land for the land use planning, where they can put new utilities depending on the population requirements. So for this planning and the master plan preparation requirement, they need to do various analysis with respect to the utilities requirements, road requirements, infrastructure requirements. And we have seen in the demo just now that using CityEngine, there was one flyover, the elevated road was created in the tool. And in addition, what we can do here is we can even perform the impact analysis, that how this, if there is an area where more and more of traffic jam is happening, then if we place one elevated road there, then how it is going to affect that area and ease out the traffic. So these kind of analysis can be built upon and performed by analysts, and then those planners, they can even perform layout and visualization not only in 2D but in a 3D as well, because in most of the cases we have 3D also plays a key role when we talk about hilly areas. Terrain is very critical when we are talking about the water placement of the water tanks and the reservoirs and other facilities. There again, this 3D role and for the visualization and analysis. And when we talk about these smart city initiatives, where we are all talking about underlying underground corridors for the utilities, there again GIS can provide us those tools for a 3D visualization, where a pipeline is going, water pipeline is going, where, what is the gap between sewer lines and a pipeline. So those kind of analysis can be done by the planner here and can be incorporated in an automated way inside their planning, inside their master plans. Now, once this planning with respect to the utilities and all is done, then they can plan for various buildings and sustainability, green buildings. We are talking about nowadays regarding those renewable energy requirements for the buildings and for the smart city. So here again, this GIS plays a key role where it provides various algorithms and where various integrated modules which can be directly utilized by various planners and can be incorporated in their decision-making process. Let us see a quick demo again and see how this GIS can be leveraged for a small, we have taken a small scenario of a Noida. Thank you. Thanks, Vinay.
Shaurudit, can you make Vinay the presentation? Yeah, thank you.
Right. Thank you so much, ma'am. This is a small section of Noida which we have taken into consideration for redevelopment activity. As here you can see in this area, you are seeing multiple facilities available. That means schools, hospitals, open area, residential buildings, some commercial buildings which is having parking lots available there for the 2 floors, and then the office space, and then some public area. So all these things can be done in CityEngine, and there are some solar panels available there on top of the building. Okay. Here at the right hand side you can see there is a usage function available from which you can control the usage of that particular building. This could be done for any of the buildings available there on the map. So once we are ready with our master plans, 1 or 2 plans available, what we can do, we can share these plans to multiple stakeholders. When I'm saying multiple stakeholders, these are the authorities which will give their approval on top of it, or if there is any suggestion which is to be given, they can give it there, then and there itself. So how we'll share it? We'll share this thing in the form of a web scene. Okay. Now we'll share it in the form of a web scene. Okay. This is a complete ArcGIS platform wherein whatever we have, whatever plans we have developed in CityEngine, all those plans can be shared here with multiple stakeholders. Okay. So this way we can share the plans with multiple stakeholders as well as the public. So if they request any kind of a facility in their area, they can very well map that thing directly onto the map, and it will get reflected. There is the dashboard available with the people sitting on the authority. So this way they can directly make the edit onto the map. So if they see there should be some green area available in this location, they can certainly map it. Then and there itself it will get uploaded there on the map, and they can click the picture, and they can very well put in their remarks there, so that the people who is there, who is ready to give the approval, they can very well see the remarks and get it done. So this way you can make the changes, or from here you can select the facility, what kind of a facility you want. So this way we can share the proposed plan with multiple stakeholders as well as with the citizens. Thank you. I would like to hand over to ma'am now. Thank you.
share my screen. Yeah, thanks, Vinay. Sorry for this hiccup here. Thanks, Vinay. Just to add whatever you have shown here, like once the plan is ready, it is posted for the crowd to take feedback from them. Here, a little bit of these roof panels, sun panel analysis, which I was talking about, that can also be done very effectively using this GIS. And here, if you see that these are the direction, even the direction of the sun and all, they are also shown here and can be analyzed and planned where those roof panels can be placed. So this was just one small addition. And then when we are talking about this planning, there is another, when I mentioned about these underground corridors, underground utility corridors, and this is again GIS. This is how this CityEngine can help us in creating and planning those different kinds of underground corridors. This can be analyzed with respect to various depths and various spans. This slide here. Yes. Sure. Yes. Okay, so coming to back to the slide here, once this planning is done, geodesigning is done, crowdsourcing is done and all, finally the released master plan is to be shared with various stakeholders, policymakers, citizens for various applications requirements. And when we are talking about these smart city applications, where we are talking about various reforms applications and all, this GIS platform provides solutions, ready to use configurable solution templates which can be configured and used and leveraged for various requirements. Creating a smarter city initiative and supporting that initiative. So typically, if you see this is a high-level solution architecture here, which this ArcGIS platform integrated with CityEngine can be implemented, which provides a complete framework for integrating data from various sources and sensors without conversions, without any delays. And once all this data is integrated here, a detailed master plan can be prepared under controlled workflows using standardized data models. And then once these master plans are released, then they can be accessed by various departments and various stakeholders for accessing in their smart applications and using it for various reform activities. So just quickly in a nutshell, if you see, these are some of the areas where GIS, the smart master plans which are created using fully geo-enabled master plans prepared using this platform, they can be accessed and leveraged in all these different key reform areas like e-governance, land use, town planning, water supplies and utilities, sewer management, solid waste management, infrastructure and all. So just, if we go here, these are just of the town planning and municipal. Then we have talking about roads and transportation. Well, there are quite a few of applications which can be created, and smart surveillance, disaster management, emergency response, stormwater modeling. So all these applications can access this particular smart master plans which are prepared using GIS and CityEngine. Thank you.
Yeah, so thank you Seema, thank you Vinay. So we'll now take, we have a few questions via chat which we have received from the participants, so we'll take those. I think the first question which came in from Mridul Nishal, I think this is he had a query about what exactly is the MIS data, what kind of data we will have in the MIS system which will actually be a part of this master plan creation. So if you can please elaborate on that.
Yeah. Mridul, thanks for your query. Well, when we are talking about any planning, and specifically when we are talking about a long-term planning for smart cities, AMRUT initiatives and all, MIS data is also equally important. But when MIS data is analyzed in MIS environments, then it's a big challenge. So what we do in master plans, we link MIS data, for example, with respect to the demographic profile of the area, where are the more, when we're talking about area profile, socioeconomic profile, infrastructure requirements, what kind of infrastructure is available when we talk about road and transportation, then traffic, MIS data with respect to the traffics, where the accidents are happening more and more. So these kind of information, which are the additional inputs which are required for analysis and decision making, these come under MIS category, and here in this GIS, we can link it and use it for master plan preparation.
Okay. So we have another question, probably Anil, I think it will be more appropriate to you. So this is coming from Hitesh Jain, who says that I have a big manufacturing unit. I think if I understand it, how can I use GIS, for my benefit?
Yeah, so for a manufacturing setup, there are various ways GIS can come, provide value. One is definitely, supply chain and sustainability. So really depends on what you're looking at. But in supply chain and sustainability, if you have, the location of various, let's say, units within your plant, or movement of raw material from, a manufacturing unit to the warehouse and things like that. So that's where GIS can actually play a lot of value, and also calculating distance between your manufacturing unit to warehouse, and then warehouse to retailer, so things like that. We can, however, get into details of it, in offline mode.
So probably if you have more queries, you can send it to us at info@eastindia.com, so we can actually, discuss it separately. We can help you understand in terms of what are the specific scenarios where GIS and CityEngine can help you further in your business. Okay, so moving again to next question. This is from Hiren Doshi. I think this came regarding one of the demos which Vinay was demonstrating, where he was showing some buildings. So his question was, are these existing buildings, or maybe it can be done with the existing area also? The analysis which Vinay was showing, that he can tilt a building, he can raise the height of the building. So it is in context to that.
You want to answer, Vinay? I'll add on.
So the buildings which I was showing, those are not the realistic buildings, but yes, those things can be done for the realistic building as well. For example, if you're having a building parcels with you and having attribute value as height available there, you can very well extrude that thing up to that particular height. And if you're creating a new zone and those height needs to be increased, you can certainly very well do that.
Okay. Yeah. Just to add here, as we are aware that there are building norms with respect to the percentage area, 20% under residential, 40% under open spaces and all. So here in the CityEngine, we can incorporate all these parameters as well, and consider those also at the time of designing.
Sure.
Yeah, Vishal.
Okay. There's another question from Shashank Shekhar, who says, what is URD PFI and how is it useful for GIS mapping?
Yeah, URDP-FI guidelines, actually this is MOUD's guidelines, where MOUD has specified each and every parameters to be considered for the preparation of master plan. For example, if there is a building of a 2.5 floors, then what is the proximity, what is the gap between the roads, what should be the gaps between the roads? If there is a building of then what should be the gap? If there is a commercial area, then what should be the gaps with respect to the roads? This is just one example actually for this building layout plans and all. Similarly, there are road parameters again available that for certain so-and-so number of population, this is the kind of traffic will be there, and then these are the widths of the roads should be planned for these requirements. So these are the standard guidelines issued by Ministry of Urban Development and are available on the ministry site. And these are considered by the planners at the time of master plan preparation.
Thank you, Seema. We have two questions coming in from Ashwini Luthra. How traffic simulation modeling can be done in a GIS platform? And the second question is associated with that can we do parking analysis also in a GIS platform?
Yeah. So coming to this first query related to this traffic analysis, here in the CityEngine, we have these tools and the parameters which we can set on the right-hand side and configure with respect to the road. For example, there is a road which was planned, which is existing, and there are certain new residential complexes planned under the master plan. Now, planner is required to understand that if some 500 buildings are added in that area, residential building will be added in that area, what is the impact going to be on the traffic in that area? So these kind of parameters, we can just change minor parameter, and using the rule-based, he can automatically, the CityEngine can, using the rule, can help that if for a kind of 500 residential locality, this is the kind of road which will be required, considering so-and-so traffic and so-and-so number of vehicles on the road at one point of time.
So those kind of algorithms are
Yes, they are available here. And then another question was parking. So that is again related to the same requirement that at the time of planning parking, Vinay has shown that building also, this commercial building with a basement as a parking and all. So those also can be planned at the time of geodesigning using CityEngine.
Thank you, Seema. There's a question which is coming from Manikandan Thangavelu, who says that currently who are the people who are using CityEngine tool, and does ISRI provide any training regarding this? So I think we do have a training option. So Mr. Manikandan, if you can just write to us at info@citysindia.com, we can share the training options. Now with respect to some of the examples of the customers who are using CityEngine, you can probably elaborate on that.
Yeah, see, well, globally there are quite a few users who are using CityEngine, and if we talk about this Mazda city and Singapore, in fact, Singapore complete that's the URA, Land Authority of Singapore, they're using CityEngine completely for their analysis and planning requirements. And these are just few examples. I mean, there are many more, Rome and others. They are using it very effectively. Here in India, yes, this is initiated. There are few organizations who has initiated with this, and there are training modules are also available, which can be taken for CityEngine learning.
Yeah. Okay. Another question which is coming from Hiren Doshi. If I have a big plot with a different structure of building, so is it quite easy to possible to draw it in CityEngine? So I think yes, that Vinay covered as well.
Yeah, it provides good tools actually to create different kind of infrastructure, facades, and different layouts, plans, and rather it will support also in automated designing and planning and laying out.
Now, another question coming from Shiny Stephen. How dependent is CityEngine on ArcGIS? So, I think so. While I don't think there's any dependency, but I think they are complementary.
Yes,
so
they are complementary.
There are some inherent strengths of CityEngine, which is primarily related to the 3D modeling part of it. And once you have that data, you can bring it into ArcGIS, and you can start doing further analysis on top of it.
Right.
So both of them, they are seamlessly integrated.
Integrated. Yeah, and to and fro, I mean, we can create a rule in CityEngine. We can directly access the geodatabase and feature layers and from the geodatabases directly in CityEngine. and use it for analysis and planning and elevations and modeling purposes. And then that same data or the outputs which are generated, they can be exported back inside ArcGIS platform. I mean, directly they can be accessed in ArcGIS platform. And we have seen also in this demo that the same CityEngine Noida sample, it was published over the web using ArcGIS platform for various stakeholders and crowds for the crowdsourcing requirements as well.
Okay, I think we have exceeded the time that we had for this particular event. I think I still have a few questions. So we are sorry we will not be able to take any further questions because we have exceeded the time. So all the questions, all the remaining questions we will respond to you one-on-one over email. So thanks everyone for joining. Shoradeep, back to you again.
Thank you very much. I would like to thank all the panel members and the participants who joined us today. Hope you all spent a useful time. With this, we conclude the session. Wish you all a great day ahead.
Just hold on. I would like to share that the presentation and the video recording will be made available to all the participants in a few days of time. Meanwhile, if you have any further questions, you can always write to us at info@isrindia.com. Yeah, thank you.
Thank you once again. Thank you, participants. With this, we end the session. Wish you all a great day ahead.
Bye.